And cool. All right. Thanks everybody for coming. So the keynote starts in about an hour and a half. So this slot is scheduled for about 45 minutes, but I'm probably only going to go about 30 so that everybody can scoot over to the keynote and get a good seat. So let you guys out a little bit early. So my name is Adam Smith. Let's go on to clicker. Works. Okay, and today we're going to be talking about optimizing your mobile AR application for the purpose of extending your battery life and also for avoiding some heating concerns that I'm betting some of you guys might be experiencing or have in the past. But first, talk for a moment about who I am. I work with a few teams at Unity, actually. So first and foremost, I work with the enterprise support team. We have Joe, Christian, some others from the ES team here and available from the enterprise support team. I see some of our awesome partners out there. Howdy, howdy. So we are the Unity side engine life of each of the most notable partners that we work with. So if you guys play some of the more notable Unity titles, we are the Unity side development efforts for that. And then also professional services is a team that we started earlier this year. So aside from just being day-to-day support life, we're now making project level contributions, and we're writing editor scripts, game features, we're doing platform ports and things of that nature directly with our largest, most notable partners. I'm as much a fan of Unity as I am an employee of Unity. I continue to make night and weekend kind of indie projects. I shipped a game on Xbox just last year, self-published that, it's doing pretty well. So I love Unity, it was my dream job, and I'm super fortunate to be here hanging out with you guys tonight. So that's enough about me. Today, again, we've already talked about, we're going to explore some simple editor settings to help you extend your battery life, mobile devices for AR, minimize device heating, which are especially important in mobile AR development. Primary goal for the talk, encourage you to consider some of your editor level settings, and then secondly, after you've considered those, are they appropriate for your project? So on the ES team, when we go do an AR project, there's two usual suspects that appear almost always, and it is the fact that battery drains quickly because it's very expensive to do AR if you don't do it in an optimized way, and because the hardware is working so hard, your battery, the device might overheat, which is not fun. So there's typically three simple optimization opportunities that we find on almost every single AR project that we touch. So we're going to talk about what those things are. But first, we want to start with the Unity profiler. So I've done this talk several times at different events, and I always like to assume that there's at least one new person in the room that is just getting their feet wet with Unity. They're only now starting to explore the technology, utilizing us to develop your application. And so while most of you are probably familiar with the profiler, what it does and the purpose it serves, I do want to talk about it for just a moment. Very easy to get to, just a window, profiler. It's a dockable window like any other editor window inside Unity. And you can look at any part of your hardware. You can look at the CPU, you can look at your GPU, and the great thing is, as you're running your project live, you can have that running in the background, and it will record all the frame data live, and then you can click into any of those green spaces, and you can scrub back and forth with your arrows, your arrow keys, and you can see exactly what percentage of your frame time is going where. And the thing for this talk that we're going to be exploring most deeply is the column that says time ms, ms meaning milliseconds, where all your CPU time is going specifically for this talk. So if you take anything away from this talk, if you're not using the Unity profiler, you don't know it exists, learn about it, use it, you really want to be utilizing it. It's one of your best weapons in identifying performance, optimization, and stability issues. So with that in mind, we now know how we're going to approach looking at CPU and GPU performance issues. And once we start knocking out some of these concerns, we're going to have a better battery life and a less heated device. So let's create less work for our hardware. So the first thing we want you to consider is your target spec for your frames per second. So when we walk into most studios that are doing AR development for the first time, most of these studios are coming from VR development. That's been a common story. And unlike VR, 30 frames per second has very much become a standard frame rate at which we see AR apps shipping. So if you have a goal for your mobile AR app to ship at 60 frames per second, it may not be the case. I've been able to observe a few playtest groups at significant studios with major IP projects, different playtest groups. One group gets a device that's 60 frames per second, one gets a device that's 30. Nobody really makes any positive or negative comment about the frame rate. And then there's mixed groups where you have the same devices handed out with random devices running either 60 or 30, and people just randomly get a device to run on. Nobody ever comments on it. And so users are not complaining about this. So if your application can stand to live at 30 frames per second, you're going to get some free things out of the box. It is very easy to clamp your target frame rate just using that simple one line of code, application.target frame rate, with whatever integer value you want to be there, but 30 is the obvious choice. So that's a pretty quick topic. But if you can take advantage of running your project at 30 frames per second, you're going to get some free things. Second, in regard to physics, we see a lot of physics-heavy AR applications. So I have this project called, I just call it a bouncy ball test. Basically, it's a bazillion balls just on a cube platform, bouncing up and down. This project is built by design to abuse the physics system within Unity. So to really make the point in this presentation. So I'm gonna show it to you real quick. You guys over there probably can't see me for the moment, but that's okay. I'm going to, you can do a laptop. I'm gonna hop over to my project very quickly. I'm just gonna show you the project. And with this being an AR-specific talk, I'm gonna throw myself up there on the screen. Hello, everybody. All right, so all that orange is physics just screaming at us. I'm going to pause this. I'm going to stop it. I'm going to swipe into that. All right, so what you're looking at here is the profiler that I was showing you earlier. Are most people familiar with what they're looking at? See about half and half. Awesome. So if you see that much orange in your project, you're doing terrible, terrible things, and we should optimize that. So that's physics just begging us for help. So if you, as I was discussing earlier, you can use your arrow keys, and you can bounce around, and on every single frame, you're going to see that fixed physics time step is going to be about 19.5 millisecond. Now, let's talk about the math of your frame rate for a minute. If you are targeting 60 frames per second, the maximum that you want your CPU to be running is 60 millisecond. If you're targeting 30 frames per second, fortunately, you're only targeting a maximum of 33 milliseconds on the CPU. So with just the scene as it is, we're already eclipsing 60 millisecond, which means we're way over budget on, for all our other game features and everything else we need to do, we have no budget left. We're capped out. We're about halfway there for targeting 30 frames per second. But we're targeting 30 frames per second. We're only using half of our bandwidth, but in the enterprise support world, that's not good enough. We don't want to come in under budget and just call it a day. We want to be as performant, optimized, and stable as possible. So we want to get the work that the hardware is doing under control. All right, so let's go back to our presentation. You've seen the project. I'll show it to you one more time. It's just a whole lot of these bouncy balls with me in the background. And then also to illustrate the point as to how much work we're actually doing, there's just like a bazillion of these balls. It's just a sea of these things. All right. So what we want to do in that case, let me maximize this one more time. There's a thing in the editor that most people are absolutely not aware of. Literally 99% of the time that we step into a studio for the first time, it could be one of the largest game developers or automotive or any other type of developer out there. This window, most people are absolutely not familiar with. So there's a thing called fixed time step within the time manager. To get to the time manager, just edit project settings time, and it's right there. The default setting for the fixed time step is 0.02. That is optimal for your time calculations for a project running between 50 and 60 frames per second. That is way too much computation happening for a project that is targeting 30 frames per second. So what is most optimal for a project running 30 frames per second? Forgive me, I'm going to take a drink of water very quickly. That's a nice sound effect. If your project is targeting 30 frames per second, you want that top field there, that float value, you want to be 0.0334. That is the maximum fixed time step you need if you're not going above 30 frames per second. So every time I've given this talk, a lot of people take pictures of this slide, so I'll leave it up there for a second. All right, and the audio is being recorded, but I gave this talk at Unite Berlin, and this same session from Berlin is online and available right now, so all the information is there. It was such a hit, they had to have me back, so. Thank you. So that's the maximum fixed time step that you want for 30 frames per second, 0.0334. Now, Like I said, this talk is going to go quickly, but the point is not just to talk to you all day. It's to give you simple things that you can take back into your studio or your home project, 3 simple things that you can just go do with a couple lines of code and a few editor settings and get a lot of impact. So third, resolution. One of the things about mobile development that most people do not know, and this is yet another usual suspect that we talk to every single studio, regardless of their stature in the world, this is something that most people just do not know. Most every mobile device set the resolution that the user experiences to be the native resolution of the device, which is gigantic. And for something the size of your hand, you probably don't need all that. So I'm going to illustrate the point here by going back to my project. I'm going to compile this application. I'll talk to you very quickly, actually. So I have this game object called Resolution Manager. And on it, you can see I've got this very simple script called resolution set. The start width and start height fields, 1080 by 2220, that is the default, that is the native resolution of one of the most popular Android devices. That is about that much screen space. So what we have found from playtest groups is that about half, not on a tablet, but on a mobile phone, about half of the native resolution, you will never hear anything from a playtest group. Nobody will notice fidelity differences or anything of that nature. So one of the things that we have found is that we always encourage studios to not use the native resolution, but most studios that we work with have settled at about 50% of the native resolution to be their target resolution. So again, those first 2 fields, 1080 by 2220, very popular resolution for an extremely successful Android device, and we're going to half that resolution. So to illustrate the point, I'm going to compile this on my desktop. Yep, replace it. We're going to build. And then we're going to open this up. All right, so that is your native resolution for most mobile devices. It's too big for my laptop screen. But I have a key code that I compress due to my script, R, and that's not where I want that to be. And that's a more appropriate resolution. It's still too big for your user's hand, but you're gonna get a whole lot of performance increase out of that. So highly recommend you don't ship with the native resolution on phone devices. So how do we aim for a different resolution? Go back to the presentation. And here we are. All right. One line of code. Dot set resolution, whatever target width and height you want. That's it. And that will allow you to set the target resolution that you desire. So now, the TLDR checklist of things, and then we're going to put all this to test. So first, frames per second, mobile AR, again, with all the insight into the awesome playtest groups that we get to experience with large major studios, almost nobody ends up shipping their mobile AR project at 60 frames per second. It's almost all 30. Second, if you're doing 30, your physics time step. Optimize it for your project. Third, your native resolution, probably not necessary. So let's put that to test. So we're gonna bounce back over to the project very quickly. Sorry about that sound effect. It's pretty cool though. All right, where'd my mouse go? Okay. Okay, so we're gonna run the profiler one more time, and we're gonna take a look at this, and it's just choking on itself right now because we're doing terrible, terrible things. All right, so we're very unoptimized there, so let's do some things. All right, so we have our frames per second manager. This is a game object I created that has a super simple script on it. It's as simple as this. I'm doing that to clamp my frame rate at 30, so I'll no longer be running at 60, I'm gonna be running at 30. Just as simple as that, one line of code. So I'm going to enable that game object, so that now happens. My resolution manager. If I were compiling this, I would do this from code, but within the editor, I'm just going to adjust it here. And then the big thing, we're going to go to Edit, Project Settings, Time, going to back this out, 0.0334, and now before I press play, again, it seems like most everybody is familiar with the profiler. And so that's the before, and now with only those 3 very simple best practices, those 3 bits of best practices enabled, This should be the before and after. I'm gonna be sad if it doesn't work, but let's see. So we went from that to that. So that one always gets the round of applause. So I'm gonna stop it. So we're gonna let that populate quickly and we're gonna take a look. All right, and so now physics is way under control. Even these spikes, which are all the balls bouncing the exact same frame, we don't really go much further than 8 milliseconds. So your project isn't going to abuse the physics system in this way, I hope. We've seen some crazy things in our years. Yeah, so we got so much frame time back. We got half our frame time back on those maximum spikes, and we're at around 4.5 millisecond on average, on our average frame. So that's a huge optimization. So back to the presentation. There we are. All right, the hardware is working much less, so that by default is going to extend your battery life and going to decrease the heat output. And there's one more thing I want to leave you guys with, and this is something that's not technical in any way, shape, or form, but it's something that we have noticed. It's been a very real topic on a number of very notable projects that we have served. There's two specific projects that we were involved with last year. One last year, one earlier this year, that keyed us off on this thing that we were seeing. We could not reproduce the heating concerns that the applications were being experienced by our developer friends. And they were sending us minimal repro projects and whatnot, and we just could not reproduce these things. And then we went on site with this one particular studio, and then I noticed something about the devices that they were using. And one of the things that I would tell you is when you're doing mobile AR development is that your user, your end user, is playing their phone, or they're playing their game with a case on their phone. And can anybody guess what these cases are fantastic at doing? Yes, you guys are awesome. One person, it was about 300 people in Berlin. One person got it, so you guys are doing awesome. Yeah, so these things trap heat like no other. I have the OtterBox on my iPhone 8. It's completely enclosed. There is no breathing room for the phone. And so what was happening was we identified the fact that it was the test suites, none of the devices had cases on them. And this seems like a brain dead thing, but it's actually really important for mobile AR dev. So you probably have good analytics on your users. You probably have those same devices in your test suite. That's awesome, makes me happy. But you really want to recreate the exact same environment that your user's phone is in, which means I would, for every device in your test suite that's targeting a mobile AR game, I would put it in a pretty enclosed case because that has been super helpful in us recreating what's actually happening on the user devices when we can't repro it in their studio or on our own devices. And with that being the case, like I said, I was going to be quick because the keynote's at 6 o'clock. I know that people want to scoot over there, so this is a slightly abbreviated version of the talk. But that's it. If you guys have any questions, I'm happy to stick around and answer some things. But yeah, thank you for coming very much, and happy to answer any questions that I can. Yes, if you want, yeah, there's mics available too. Okay. They're requesting that we get you on the mic.
When you give the number for downraising the resolution, is it important to downraise by a factor of 2, or can you downraise by an arbitrary number?
You can downraise by an arbitrary number. We have just found that it's about half where people settle. There's nothing in regard to factor 2 being important for texture compressions. You want to do things in power 2 nature, but in this regard, it doesn't make any impact.
Gotcha, thank you.
Yes, sir.
Do any of these setting changes affect the camera feed, especially in terms of frame rate, or is it going to be using a native camera frame rate in terms of the stuff coming from your camera versus the objects being created?
No. So I mean, it's going to project from your camera just the same as it would any other camera. It's not going to cause any distortion. If you're using post-processing, depth of field or anything of that nature, it's not going to affect the visual fidelity. It's just going to be doing half the work. So I mean, effectively, you're going to be missing every other frame at 30 versus 60. But it doesn't cause any distortion or anything of that nature. I guess if the human eye were able to see things at the most rapid pace, I mean, I guess that a depth of field or post-processing type visual effect, it might be the case that something might not be as fluid in the transition from frame to frame.
Yeah, I was wondering for resolution, especially if I make an iPad app Am I going to notice, in changing the resolution in Unity, am I going to change that native resolution coming out of the camera, and will that be sensed?
No, you won't be changing the resolution out of the camera. But think of it this way. So if you're developing an application that has a 64 by 64 like sprite as an icon in the UI or whatnot, actually, if you were running at native resolution, that 64 by 64 icon is going to get blown up on these huge devices. And the distortion that you would see or the fidelity loss would be because it is being blown up. So shrinking it is not going to cause a loss of fidelity. But if you were running maybe like an iPad Pro or something with an enormous screen, then you might see something because a texture might be too small. But shrinking it, you shouldn't see a fidelity impact. If you do, though, I'm happy to, if there was anything of that nature, forward it on to us. But we haven't experienced anything of that nature, and we ship hundreds of projects every year, and we do this on almost every project we touch.
Thanks.
Yes, sir. Yes, sir.
So if I'm targeting multiple aspect ratios for this set resolution, is there an easy way? You had one line of code, but
yeah. So let me show you my script. There's a way you could do this. Basically, what you'd want to do. Let me go back to Visual Studio quickly. The way that you would do that. So here's the actual script. So right here, I've just got public integer values to set my target width and height. But what you would want to do is on start or awake, probably on awake, you would want to say, you would want to get screen.get resolution width and height. And then in one more line of code beyond that, you would want to say that the screen set resolution target width and height be native resolution, whatever the width and height divided by 2. Effectively, that's how you'd want it. You just want to do the math that way.
Right,
does that make sense?
Yep, thanks.
Yeah. Yes, sir. Joe, you're smiling. Did I say something weird?
So with
Yes.
regards to that script, actually, are you recommending just any old game object or one in particular?
So I like to do it on a game object so that I can do it at runtime instead of at the project level. So for the question the gentleman just asked, so that I can, like if I'm doing a mobile, especially on Android where there's a random device and whatever country we're in and we don't really know all the make and models and we don't know the resolutions for each, what we can do is just read it from the device and say this is the resolution and height. So I like to do it on a game object on awake so that I can get the resolution from the device instead of trying to account for all those in some like monolithic script that says this device should equal this resolution. Personally, what we've seen done most effectively is just ask the device on awake for the native resolution width and height and divide it by 2 and say that's my set resolution value.
Do you devote a game object to this or just hang it on any old one?
Oh, you can put it on anyone. In my project, I have it just for the ease of displaying it in a session like this. I have a resolution manager with that attached, but you could put that anywhere you want. You would just want to make sure that you have it on a game object that is already loaded into the hierarchy of your first scene. So whatever your loading screen is, you definitely want to do it there. Yep.
Yeah, I was just going to ask about, is this something that you really would want to hang around, or once it's been set by the first scene, it's set and...
you can dispose of it.
Okay.
You can do like a game object.destroy or whatever you want to do. You can get rid of it at that point.
Yeah, I was thinking going the other way of saying don't destroy on load, or don't destroy this object, but...
So just for order of operations, it's completely safe. This will happen on the first frame of your game. If you do this in the awake function on your scene 0, it will happen no matter what.
Okay, thanks.
I just sleep easier if I kill it when I load out of the scene the first time, then I don't reload it. Yeah. Anybody else? Okay, perfect. All right, well, thanks everybody for coming, and then we'll all be hanging out at the keynote, so we'll see you there. Thanks, everybody. Bye.